I'm here today to talk to you about 12 things about Oracle Database 12c, the latest generation database technology from Oracle. This was hard to put together because I had to start with a list of over 500 new things inside the database. I whittled that down to about 80 and then kept sorting and resorting that and came up with 12 features that run from the simple to the really high end. So for the first one, it's even better PL SQL from SQL. Starting in 12, you'll have the ability to start a SQL statement with a bit of PL SQL code. So you could go with function f is and define the body of a function and have it be compiled into the SQL statement basically, rather than having to compile it at the command line and grant permissions on it and have it be a persistent schema object inside your database. So even better PL SQL from SQL. Number two, some improved defaults. For a long time, I've wished that we could default a database column to be populated by a sequence number. Well, now in Database 12c, you can in fact do that. Not only can you default a column to be populated by a sequence.next file, but you can use a new data type of sorts. It's called an identity. So you could declare some column to be an identity type and will automatically create the sequence for you and populate those values. And of course you have control over the sequence values that are generated as well. In addition, we have the ability to have a column that defaults to a value on null. So in the past, if you had a default value, it would only be used if you didn't put that column in the insert at all. Now you can put that column in the insert, and if you insert a null value, we'll supply a default for it. Additionally, in the area of improved defaults, you can now fast add a column with a default value, even if it's nullable. In the past, if you added a column with a default value and it was not null, we could add that in milliseconds because we didn't really have to touch the data. Now we've extended that to any column that you add with a default value, regardless of whether it allows nulls or not. Next, number three, increase size limits for some data types, specifically varchars, nvarchars, and raw data types. So I remember way back in version 7.3, columns had a maximum width of 255 characters. In 8.0, we extended that to 4,000, and that seemed like a lot at the time. But over the years, our needs have changed, and so has the size of this data type. Now in Oracle Database 12c, a varchar can go up to 32K, just like it can inside of a PL SQL block. So now we have better parity between the PL SQL types and the SQL types. Number four, easy top-end and pagination queries. This is something people have been looking for a while. I've written no less than 3 articles in the magazine on how to do top-end queries and pagination queries. It's a question that comes up frequently. In Oracle Database 12c, there's a new row limiting clause, similar to the ones you might have seen in other databases, but it allows you easily to say, run this query and give me rows 5 through 10. Give me rows 100 through 120. So it will make getting the top 10 records, the top N records, and just paginating through a result set pretty easy. Number 5, row pattern matching. Many times our data has patterns. Think of stock quotes, for example. People are looking for V patterns or W patterns in that data. That is, they're looking for a series of rows where the stock price started at some high value, and over time it decreased, hit a bottom value, and then started to go back up. That would be a V pattern. A lot of times people might want to buy on the double dip. They want to buy on the second part of that V, the W shape. Well, now inside of SQL, you can set up a pattern matching clause that, using a regular expression like syntax, you can describe to us the pattern that you're looking for in the data. So you can look for those V's, you can look for those W shapes inside of the data as we're streaming through the rows. Number 6, lots of partitioning improvements. Things like the ability to do multiple operations on multiple partitions simultaneously inside of a single DDL statement. In addition, we have the ability to do reference and interval partitioning together. Another great enhancement is the ability to move a partition of data online without having to use DBMS redefinition. So you're able to move a partition from one set of storage to another, maybe to compress it, maybe to move it to cheaper storage, while that table is online, while people are still transacting against that data. Lastly, the ability to have asynchronous maintenance of global indexes against our partitions. So with asynchronous global index maintenance, you have the ability to perform the partition operation, say a drop or a truncate, and then in the background later, when there's time available, we will come along and clean up that global index. So you can drop the data, but still have continuous query capability against all of your data. Number 7, adaptive execution plans. This is the ability for a SQL plan to sort of change its mind halfway through its execution. With the adaptive execution plans, we can really have 2 plans inside of one, so that as the optimizer, as the database is running that query plan, it can evaluate how many rows it actually retrieved from a step in the plan and decide whether it wants to continue using the nested loops or if it wants to switch into a hash join. So the query plan has the actual ability to adapt at runtime. We don't have to make a mistake and then figure out we made a mistake. We can, while we're running that query, figure out that, hey, what we were thinking about doing is the wrong idea, and switch the plan right then and there. Number 8, enhanced statistics. There's a lot of advancements in statistics inside of database 12c. So for example, there's a new kind of histogram. There's actually 2 new kinds of histograms, and they deal much better with covering sets of data that have more than 255 distinct values in a column. In the past, if you had more than 255 distinct values in a column, the only thing we could do is give you a height balanced histogram. That had certain issues with certain types of data skew. For example, if you had a column that had some really, really popular values and some really, really unpopular values, but then a whole set of columns that were nearly popular, they had lots of values, but not nearly as much as the really popular columns, we could come up with some really bad cardinality estimates based on the way they were fit into the histogram. Well, with a new type of histogram in Oracle Database 12c, we can better cover those unpopular, almost popular, and very popular columns. Additionally, we have the ability to automatically compute statistics during your data loads. So if you do a create table as select or a direct path load into an empty table, we'll have automatically computed statistics for that during the load so that you won't have to come back and do that. Number 9, temporary undo. When people started using global temporary tables, they were very surprised to discover that temporary tables, which are in temp, generated redo, which is for persistent objects. The reason they discovered is that temporary tables generate undo. They have to generate undo because we have to be able to roll back an operation against a global temporary table. We need to support consistent reads against those temporary tables. So they need undo. By generating undo, however, they needed to also generate redo to protect that undo information in the undo table space. Well, starting in Oracle Database 12c, we have the ability to store the undo for temporary tables in the temporary table space itself. This is going to be great for sites that are running things like DataGuard, for example. We won't have to ship the undo for temporary information from the production site to the standby site. If you're running in archive log mode, it won't be part of your backup anymore. It will be in the temporary table space. And additionally, it will make flashback query and flashback operations in general even more useful, because the only information that will be in the undo table space is the information for your data. And for number 10, we have some new data optimization capabilities. Typically, these are known as Information Lifecycle Management, ILM capabilities. But the database is now generating a heat map for our tables. So down to the block level, it's remembering what blocks are being read and written frequently, which blocks are just being read, and which blocks are not being read very much at all, if at all, and never being written to. And we're associating a temperature with these 3 types of database blocks: hot for the read-write, warm for the read-only, and cold for the hardly ever read. Now, we have the ability to, in a declarative DDL fashion, describe to the database how we'd like to deal with these blocks or treat them. So for example, we might want to set up a policy, a declarative policy that says hot blocks, we want to use OLTP compression, maybe get a 3-to-1 compression rate on that. Those warm blocks, we'd like to move that data out of the hot and put it into a place where we're getting query compression against that. Maybe we're getting a 10-to-1 compression ratio. We're still reading it frequently. We're not writing to it very much, if at all, so we'd like to compress it even more. And then later on, maybe after it's been in that warm segment for 30 days and it's become cold, we might move it into an archive compressed location inside the database. And so here the DBA, instead of setting up scripts to move this data around on a time basis, is setting up a policy that describes hot, warm, and cold to us, and then another policy declaratively that tells us what to do with this information as it becomes warm and cold. Move it from here to there, compress it to this level, and so on. So it's more of a declarative approach rather than scripting and running on a schedule. Next, number 11, application continuity and transaction guard. These are two features that sort of work together. Transaction guard is the ability of the database to ensure that a transaction happens at least once and at most once. We've all been on websites where you fill in the form, put in your credit card number, and hit the submit button, and it says, don't hit that button again, otherwise we may charge your credit card twice. Transaction guard is designed to remove that from reality so that you don't accidentally order 2 sets of flowers, that you don't accidentally order 2 plane tickets. With transaction guard, the application can make it so that they know whether a transaction has actually taken place or not, even if you hit the enter key twice. Building on top of that is a capability called application continuity. This is an extension of transparent application failover, TAF. In the past, with TAF, we've had the ability to transparently fail your application over from one database to another if it was performing a read-only transaction. So if you had processed a couple of queries, generating a report, and the database failed for whatever reason, we could fail your read-only transaction over to another node, another database, and pick it up where it left off. We couldn't do that, however, for read-write transactions. Application continuity allows us to do that for many read-write transactions so that we can pick up your transaction where it left off, replay it, and rejoin you with that transaction in the other node in another database. Last but not least, number 12, pluggable databases. This allows us to basically perform database consolidation on a scale that we could never before. A problem with consolidating databases in the past has been you couldn't take 2 general databases and merge them together into a single database instance. Problems you would run into would be they both have a public synonym that collide with each other, so you couldn't merge those 2 databases together. Or they would use the same schema name, so you couldn't merge them together. Or it could be as simple as the 2 owners of those databases didn't want their data commingled with the other person's data. My DBA shouldn't be able to see your data, and your DBA shouldn't be able to see mine. Enter a pluggable database. This gives us the ability to run one Oracle instance, a set of processes in memory, and then plug into it up to 252 other databases. These databases all share the same set of processes, so you don't have the 20 processes per database. If you had 100 databases, you would typically have upwards of 2,000 processes for that. If you're using the pluggable database architecture, 100 databases, you'd have 20 of those processes. You have one SGA that all of these databases share. That one SGA will be significantly smaller than the 100 individual SGAs you would have needed otherwise. So this pluggable database gives us an architecture for actually performing database consolidation. Now I just don't dump 30 or 40 databases on a machine and run with it. I'm going to have one database that I upgrade, that I back up, that I recover, that I use DataGuard with, that I configure for rack, but then I can plug in all of these other databases and they inherit all those attributes. So for example, if I've set up a container database that I can plug other ones into and it's in a DataGuard environment, every database I plug into that will automatically have DataGuard provided for it. The backup that I put in place for the container database is the backup that's in place for all the pluggable databases as well. So this really eases the management of multiple databases on a single host. We can even do resource management across those individual databases for the first time. This allows you to put 30 or 40 databases on a machine and actually manage them, resource manage them, backup manage them, DataGuard manage them, and so on. So that was 12 things about 12c. I hope you found it useful and enjoyable. But remember, there's at least 488 other things about the database out there to learn about. So I encourage you to read the What's New In documentation available on otn.oracle.com.